All right, in this video, we are going over the first trend here, which is some indication of acceleration, velocity, or position. But I will preface that you will see the majority of questions leaning towards acceleration or position, because for the most part, they'll give you velocity and you'll have to use calculus to go forwards and backwards to acceleration and position. Okay, so here we go. I'll try to go over some non-calculator questions as well as calculator active questions, okay? All right, so my highlight is yellow. Let's start off with 2003B, just so that's straightforward. So right here, you're going to notice that this is number 4. So that's non-calculator, okay? So we have to do things by hand, okay? And again, do this on a separate sheet so that's not all over the place. But here we go. So you have to understand that if you're given velocity and you want acceleration, you have to take the derivative. It's SVA, position, velocity, acceleration. Position is really S, okay? It was just lost in translation. So to go downwards, you have to take the derivative, okay? To go back up, you have to take the integral. That's all you got to remember. So velocity going to acceleration, we're going to take, this is exactly how I would write it, okay? V prime of t equals, so the derivative of -1 is just 0. E to the 1 minus t, there's a function and a function, so the chain rule is going to be E, derivative of the outside, of the same inside, times derivative of the inside, which is -1. Make sure you understood that before we move on, okay? That is the general acceleration. Now we want to find the acceleration at time 3. So that'll be e to the 1 minus 3 times -1. Here's the cool thing about it. The moment you plug in your value, you can leave it because, once again, equal is equal. Okay? Don't try to simplify this or clean it up for the AP reader. They're not going to give you any brownie points for that. Okay? So let's take a look at the scoring guidelines. All right. So that was 2004B. Oh, wait, it's 2003. Okay. So this one here is an easy 2-pointer. You get 1 point for the general derivative and for plugging in 3. They went all the way through. Remember, not needed, not required. Equal is equal. Okay? I can't stress that enough. Equal is equal. Take advantage of it. It's a strategy that will get you guys to not lose critical points that you need to pass this exam, okay? Or to get the score that you want, I should say. So yeah, 2 points. Remember, the minimum is 3, so you're almost already there, and we haven't even done the other 3 parts, okay? All right. Let's do maybe... let's see what else is worthy of doing. I mean, okay, so in 2008, it doesn't quite fall under the same patterns of working analytically. It's more analytical. In part D here, you'll notice that it says during what time intervals, if any, is the acceleration of the particle negative. So you have to remember graph analysis. When acceleration or the second derivative is negative, that implies that velocity is decreasing. The first derivative is decreasing. Okay? So it says during what time intervals, if any, is the acceleration of the particle negative? So very conveniently, they give you the graph of V. So where is V decreasing, right? Where is V going downwards? So it looks like V is going downwards from 0 to 1 and from 4 to 6. And that's it. But how do you actually write it out? Because you can't just color in the graph, right? So how do we do this formally? So here's what you guys would write. And you want to practice this, okay? You're going to say from 0 to 1 and from 4 to 6 since v of t is decreasing. So they're asking you, where's the acceleration negative? Boom, right there, from 0 to 1, from 4 to 6, since v of t is decreasing. So back when I had you guys do graph analysis, I stressed so heavily on you being able to explain your answer, right? It was in your Flipgrid video as well. So there you have it, a little bit of both. Okay, so here, let's see. Yeah, we could do this one. So, you know, there are a lot of parts in this problem, right? And it can be a little bit overwhelming, especially if there's a lot of words going on, right? But you focus on the points that you can get. So take a look at 2010B. Notice how this is a non-calculator question because it's number 6. In part C, it says find the acceleration of the particle at time t equals 3. Okay. So you look for the particle P. So if you read this question here, it talks about 2 particles. Position of particle P is given by this here. Okay, and again, do this on a separate sheet. So to find the acceleration, I'm going to have to go ahead and find the derivative twice. So here's the first derivative. The 2 is just a coefficient. Cosine of pi over 4t is a chain rule, so that's the derivative of the outside, negative sine, of the same inside, pi over 4t, times derivative of the inside, which is pi over 4. Okay? Now, since I have to go all the way to acceleration, I am going to kind of clean this up a bit. This is really negative 2 pi over 4, or negative pi over 2 if I reduce, sine of pi over 4t. To get to the second derivative, I just take the derivative one more time. It'll be negative pi over 2, the derivative of the outside, which is cosine, of the same inside, pi over 4t. I know I'm writing all over the place here, times derivative of the inside, which is pi over 4. Okay, and now that I have my second derivative, which is my acceleration, they're asking for the acceleration at t equals 3. Again, I'll do this in red so you guys can focus on it. All you gotta do is plug in that number, and then you leave everything else as is. And why can we do that? Because equal is equal, okay? Let the AP readers do the work, all right? And there you have it, okay? Now, if it's a calculator active question, let me try to find one here, like this one, okay? Very important. So I can tell that this 2003A is a calculator active question because it's a number 2. So you know it's calculator active. You can use it. All right. In part A here, they're asking you to find the acceleration, right? So to go from velocity to acceleration, you would have to just take the derivative. So the thing is, you don't have to do things by hand. Okay? When it's a calculator active question, you want to do it using a calculator. So all you got to do is plug this in for y1. Okay, this whole thing here. And then you use your calculator. You go to math 8, d over dx of alpha trace y1 evaluated at x equals 2 because that's the time they were interested in. Boom. And that's it. You get your answer. I'm sure that's an easy 1-point question there. All right. Let me see if there are any position questions. Let's see. Oh. Okay. So here's what we do. Okay, so if you notice throughout all of these problems, they always tend to give you velocity because when you're at velocity, you can move forward to acceleration or backwards to position. It's very convenient, okay? And plus it really tests your skills on derivatives and integrals. To go back to position, you would have to take the integral, okay? So here's what you do. You're going to go ahead and integrate v of t. And now, this is number 3, but since, I think it was 2015 where they started making 2 calculator questions instead of 3. So anything prior to that, there were 3 questions. So this one is actually calculator active, okay? So that's why I said sometimes 3. What we're going to do here is we could actually integrate velocity, because that'll give us position, okay? And what we're going to do here is, I'm trying to figure out which way is the easiest. Give me 1 second. You know what? I'm going to cheat a little bit. Let me take a look at the scoring guidelines. 2002. And it's not because I don't know it. It's because I want to make sure that you're using the easiest route. Okay. Okay. Where was I? Okay, so this kind of goes back to the accumulation problem, okay? So what we're going to do here is we're actually going to integrate v of t, okay? And you're going to go ahead and plug in your bounds, and this is where it's probably the most important. At the very top, you're going to include the time that you're interested in. So in this case, we want to know what the position is at t equals 4, so I'm going to put 4 up here. Okay, this is what you want. At the bottom is what you're given, the time that you're given, and you kind of have to read through here. They give you a condition right here. They tell you that at t equals 0, the position is at 2. So I'm going to put in t equals 0 here. Okay, so what this represents, let me color this in so you guys can kind of really think about this. Just this itself is how much you've accumulated, meaning how much you've moved from t equals 0 to t equals 4. Okay? This is your displacement. Okay? So for instance, if I told you guys to move 3 spaces forward, you know, can you definitively tell me where you are, right? That was a bad example. Suppose you guys were standing on the number line. Okay? Suppose you guys are standing on the number line, and I told you to take 2 steps to the right. Okay? Could you guys tell me where you are? Okay? The short answer to that is no. Okay? And a lot of you said, well, I'm on 2. Well, the thing is, the only way that you're on 2 is if I told you to stand at 0. Right? I only told you to move 2 spaces to the right, but from where? So you have to consider how much or where you started. This is kind of like back with accumulation, okay? So you want to know where you started. So we're going to find out what our position is at t equals 0, okay? And this is how we're going to find out where our position is at the beginning. And this is how you set it up. If I want to know a position at 4, I got to consider where I started plus how much I've accumulated. Hopefully you see the similarities there, okay? This one becomes a quick plug and chug because x of 0 is really just 2 from up here. And that red or that teal, is it teal or turquoise? I don't know. That highlight there, you could just plug and chug into your calculator. You can go math 9 from 0 to 4 of y1 dx. Okay, assuming that you put it into y1 there. And then you get your answer. Okay, let me find another one just to make sure you guys have patterns here. Do we have another position one? I thought I saw one at the beginning. Sorry to make you dizzy. But let's do one more before we move on. Okay, like this one. Actually, no, that's a terrible one because there's several parts to it. Let's do this one here, okay? And again, usually number 3 is non-calculator, but since it's before 2015, you know that this is calculator active, okay? Meaning we can use our calculator. Go ahead and try this one here. And press play when you're ready or if you're stuck, okay? So we want to find the position of the particle at t equals 2. So we want the position of the particle at t equals 2. So that's x of 2, okay? So I know that I have to integrate velocity. Okay, notice how I left the space there intentionally. The upper bound is going to be what I want, so I'm going to put 2, right? Down below is what I'm given, so t equals 0 right here. But then I also have to consider where I started, which is x of 0. Okay? And there you have it. That's the setup. Hopefully you see the patterns. X of 0 is 8. That's where you started. This entire integral here is basically how much you've moved, okay? Your displacement. And that there you could just plug and chug into your calculator. Okay? Try to get it to match the scoring guidelines. And if you can't, just let me know. And I'll go over it with you. Okay? In general, that's what it is for acceleration and position. You won't see too many velocities because generally they'll give that to you. But go for it. Okay? Text me if you have questions.